So my name is Benji Meltzer. As mentioned, I'm one of the co-founders and the CTO of Aerobotics. I'm an engineer by training, studied mechatronics engineering at the University of Cape Town, which is where I met James Patterson, who is my co-founder and our CEO. My personal interests are very much in the data science and specifically computer vision space. I studied a master's at Imperial College London in neurotechnology. And I guess just for context, my partner James's background is that he grew up on a farm in the Western Cape in South Africa. After studying mechatronics at UCT, he went on to MIT to study astro and aeronautical engineering. And his specific interests are very much in unmanned aerial vehicles and designing autonomous flight systems. And yeah, we came back after working a couple jobs and studying our masters to South Africa about 8 years ago now. So what was the beginning of 2014 to start Aerobotics with the vision that we wanted to help farmers optimize production through things like early problem detection, problems in this case being pest, disease, irrigation, deficiency, using aerial imagery. So at the time, drone technology was still quite new for sort of commercial use cases. And with our technical backgrounds, we saw an opportunity to build systems to help kind of automate and help farmers collect this data at scale. And yeah, in terms of today's presentation, it's obviously quite a short period of time, but I've got a few slides just talking through a bit more detail on what we do, the problems that we solve, and I go into some detail with one use case in yield estimation in particular, and talk a bit more technically on how we achieve that and what we're working on. So yeah, I'll try to leave some time at the end for questions in case there are any. So let me see if I can work this. Yeah, so just for context, we focus very much on high value crops, fruit and nuts in particular. And I mean, in this domain, along with other agricultural domains, collecting data in field is extremely difficult. It requires a lot of manual work. You know, walk up and down the orchard, sort of climb into individual trees. And as a result, making any sort of data-driven decision is, one, extremely difficult, and two, just quite expensive to do. And historically, a lot of this data just doesn't exist in the first place in any sort of structured format because it's been so difficult to collect at scale. So what we do is, I mentioned earlier, use primarily aerial imagery to try and create this data set sort of to begin with. And essentially, we fly drones as our core source of data and map and identify each individual tree on the farm. We digitize each of those trees into sort of records in the database that we're able to track. And on the left there, just as an example of the type of granularity of imagery that we're collecting, where we get sort of sub-centimeter level precision on a tree-by-tree basis, allowing for much more granular data to be measured and interpreted. Just in terms of like the size of the data sets that we've collected to date, there's over 150 million trees that we've now mapped. That meaning that for each of those trees, we've segmented out the canopy of the tree from aerial imagery and run analytics on the performance of that tree from a number of different facets, which I'll talk through in a couple slides' time. We've also built a new product in yield estimation, which I'll talk to at the end of this deck, where we detect individual fruit. So sort of going more granular from the tree level down to a fruit by fruit perspective, where it's just a new product that we're getting up and running, and we've gone through. It's actually about 10 million fruit as of today. And just another application is on pest and disease identification and diagnosis, where here we actually crowdsource data from farmers who share geo information on where they're seeing pest disease, nutrition deficiencies, etc. in the orchard. And we correlate with that with our tree level information to work on predictive models that can automatically detect these moving forward. So the data sets are starting to get quite scalable. Collecting this data can be super expensive and difficult. And that's really where we've prided ourselves over time, is building sort of scalable systems to collect this data at high quality and accuracy. Just one note, I mentioned that the drone is the core source of information for us. And I mean, historically, we actually used to build our own drones, our own sensors, etc. With time, we've become agnostic to some extent and sort of work with multiple types of aerial imagery. So do quite a lot of work with satellite data, low spatial resolution data, high spatial resolution data, different types of spectra in analyzing that data. Also working with manned aeroplanes, and a couple other sort of platforms as we go. So yeah, just I guess last piece of context on the company. We're based in South Africa, which is where I'm from originally, and James is from. We build all of our technology locally, side by side with local farmers. The big reason in starting the company here is South Africa's got access to super technically savvy farmers and quite sort of innovative base of users. And what we've done is taken that technology and started distributing it around the world now with some level of success. The US is our main market at the moment. About 80% of our business is coming from the States. There we work primarily with growers in selling the types of products that I'll cover in the rest of this presentation, but we're also working with other stakeholders in the agri supply chain. So as I mentioned, this data historically just doesn't exist in the first place, and we found quite unique opportunities to almost use this data to help transactions take place throughout the supply chain. So examples there are chemical companies selling products to farmers, or financial services companies. So crop insurance is a big market for us, where this information can really help understand how you can sell a better product and measure the efficacy of that product. And yeah, we're in about 18 countries at the moment around the world, and growing somewhat quickly at the moment, but very much sort of headquartered and focused within South Africa. So what the platform does on our side is there's a number of different aspects that we help the grower with. Just talking about each of these quite quickly, there's crop inventory management. So this is relating to giving a sort of census level information on the number of trees on the farm, the health of the trees, the quality of the trees, etc. And we find that a lot of the farms that we work with, particularly in the US, like at the scale that we're operating at, this information just often is completely inaccurate that the farmer has to begin with, and bringing precision to these numbers allows for much better sort of sense of the asset base and the trees that you've got on the farm. There's crop protection monitoring, which is very much around pest and disease management and helping the farmers detect problems early, which at the moment is just very, very difficult to do. Diagnose what those problems are and decide on some sort of intervention to correct for them. And our technology helps sort of manage that process. There's soil correlation analysis. So a lot of the work that we do is by measuring the canopy of the plant and the impact of pest, disease, etc. on the plant itself. We also look at the soil as a sort of underlying metric and do some interesting correlations with that in our data. Irrigation distribution uniformity. This is looking at the water stress that's being created in the plants and helping farmers optimize irrigation processes and patterns to basically work towards uniformity, where different plants on the farm are operating at similar levels of stress and performance. This is obviously a very, very relevant topic now as water shortage and sort of climate change becomes more and more of a relevant topic. And we're seeing quite a lot of traction with this specific product. There's also yield estimation and harvest. I'll deep dive this at the end of this presentation, but this is really helping estimate at a point in time what is on your trees in terms of number of fruit, size of fruit, quality of fruit, etc., and projecting through to harvest what you could expect that to be sort of a few months from the time of data collection. This information, you can imagine, is very, very interesting and useful within the supply chain. The final sort of aspect of the platform that we look at is just general crop performance monitoring. Here we use multispectral data to measure the health of individual plants, and we're able to quantitatively track on a plant-by-plant level how that plant is doing. This would often, the performance would be caused, or poor performance could be caused by pest, disease, irrigation related issues, etc. But this is just giving you a sort of quantitative way to track that over time. So just, I guess, a point of interest in terms of how the actual business model works and our operations work is, I mentioned that the drone platform is the core sort of platform that we use to collect this data. We used to build these drones ourselves. At the moment, we've sort of shifted to using off-the-shelf products as it has become more and more commoditized. And we basically have a set of hardware that we support. We've built embedded systems that runs on this hardware just to make sure that it collects data according to the requirements and specifications that we have. And we work largely with third-party pilots or service providers to fly and collect this data on our behalf. This is for a number of reasons, main one just being the scalability of that model versus us operating them ourselves. And we found that there's actually quite a sort of wide supply of pilots around the world that we could tap into. So at the moment, we've actually just passed about 150 companies around the world that fly on our behalf. Where basically we sign a farmer up on a seasonal basis, and we'll decide on sort of specific times during the phenological cycle of that plant to come and fly the drone to collect the required data. There are cases where farmers fly themselves, which is very much a vision that we've had to kind of build towards. But we found that the service model actually works quite well in a number of our countries. And we've built all of the sort of supporting infrastructure for the pilots themselves to plan their flights, operate. We measure the quality of the data that's being collected and help them sort of build a profitable and successful business. In terms of how the platform works is the drone, so just focusing on drone data for the time being. The drone flies and has different sensors on the drone that are collecting different layers of information. Those layers include a visual sort of bird's eye view of your crop. So this is just aerial visual imagery or RGB imagery that's stitched into georeferenced maps. We collect also multispectral data, which I mentioned earlier. This is specifically parts of the near-infrared spectrum which relate to vegetation health or stress. And we generate maps looking on a pixel-by-pixel level at how the sort of vegetation or crop is doing. And using things like photogrammetry, we also build three-dimensional models of the crop that we're mapping. So we generate all of these layers of maps essentially on a farm level. We then take this data and run a number of computer vision models on that to do things like detect individual trees. So I mentioned earlier about 150 million trees in the database, which we've run our model on and detected canopies and analyzed the tree by tree level. And you can see an example of that on the top right. Each of these trees has analytics that are calculated from the underlying layers of data that have been collected in that first image, which allow us to track sort of on a tree by tree level things like the health of the tree, the canopy area or size of the tree. We can measure the volume and height of the tree of the 3D model, and really get quite granular measurements on how the performance of that individual tree is going. There's the fruit side of things, which I won't dive into too much now because I've got some slides at the end, but there's also a product on the yield estimation side, which actually allows us to collect data on a fruit level. And basically what we focus on is taking all of this really, really granular information on fruit or trees and aggregating it up in ways that sort of downsampled in a way that the farmer can make decisions on a farm level. So at the bottom right there, you'll see an example of sort of us building trends and views where you could spatially and temporally understand where problems might be accumulating on the farm. But the real value of the granularity is to sort of cut out the noise and get low-level, accurate information that can be aggregated up to make these types of decisions. So just for the next few slides, got a couple of examples of some of these use cases and what they look like. This is one feature or part of the product that I mentioned earlier in distribution uniformity for irrigation. Basically, how this works is, here we fly with actually a thermal sensor on the drone. So it's measuring the far infrared range of the spectrum and measuring the temperature of the trees at a point in time. And we time this quite carefully with the irrigation cycle on the farm and run sort of quite specific models on a crop level, geography level, soil level, etc. And we found that we're quite accurately able to measure the irrigation stress or water stress of an individual tree. So in this diagram on the right, you could see the kind of colors represent the temperature and related irrigation stress of that tree, where ideally from a farmer's perspective, you'd have each tree in a block performing in the same way from an irrigation stress perspective, because that means that you could apply the same irrigation strategy and schedule to them. And basically what we're looking for is these spatial non-uniformities, which we can highlight to growers and potentially identify some problem in the irrigation plan. So maybe nozzles are blocked on the drip line irrigation, or there's a leak or whatever it might be, or just show that different plants are transpiring differently on the farm and require different levels of irrigation. And that really talks to precision agriculture as a whole, where the whole sort of premise of what we do is allowing farmers to treat each tree based on its actual performance, rather than just blindly applying some sort of application across the farm. Obviously, this is all assuming that the underlying systems are capable of adjusting to the level of precision needed. The other sort of product that I mentioned is on crop performance monitoring. And the way that this is presented to the farmer is through a sort of high-level dashboard where you can monitor individual blocks on the farm or orchards. And all of the analytics that we're calculating at this granular level are aggregated up in a way that they can identify trends over both space and time. So you could view things like the average performance or health of an individual block. You could compare that across your different blocks. You could group by cultivar, by crop type. We're working now on benchmarking and allowing you to compare to industry as a whole. Just an added benefit of having this sort of scale of data set that we've got. And also just in time measuring how things are changing and identifying some sort of a trajectory in terms of how the uniformity of a block is changing with time, so that the variance of these different measures is ideally decreasing, or the average performance is increasing, and looking at a few different sort of statistical ways of calculating this data. And then just for the rest of this presentation, I wanted to focus in on one specific use case, being our yield estimation technology, which I think technically is probably the most interesting problem that we're trying to solve at the moment, where the sort of requirement here from a product perspective is to help farmers measure at a point in time what's on the trees, and sort of projecting that through to harvest, creating a forecast on what they could expect. At the moment, the way that this is done is through super sort of low-level sampling, where farmers go into individual trees, look at those trees on some sort of a sample level and count a number of fruit. And this is extrapolated then based on institutional knowledge, I guess, that they've got across the rest of the farm. And really what we're trying to do is bring a more sort of data-driven and consistent approach to the same methodology to help collect more accurate measurements in the farm and of the individual fruit, and build more sort of consistent models that can extrapolate, those measurements onto a wider level. So the way that it works, this product is slightly different to what I've mentioned before, in that we've already mapped out individual blocks on the farm. So we've got plant level information on how each of those plants are doing. We then decide on a sampling strategy within the block where we'll go and collect fruit level information. And this is done using the irrigation stress information that we've measured, the crop performance information, etc., where we'll decide on the sampling route that we'd like to collect data on. And we then use a similar approach where the drone flies in to collect this data using a mobile application to control it, and now flies about 1 to 2 meters away from the individual trees. The drone collects this information, this imagery gets uploaded to our servers, and we process this to extract fruit level measurements. And this is done through, again, just computer vision models that are detecting the individual fruit on the tree. And there's then a whole lot of models that we run on that data to analyze the fruit, similarly to how we analyze trees on the higher level, and build some sort of domain models on top of that to extrapolate through to harvest. So yeah, the way that the pipeline works, just getting a little bit more technical for the last couple minutes, is the drone imagery gets uploaded, we detect and segment the individual fruits. There's some cleaning that we run on that data. We extract metrics like the size of the fruit, the color of the fruit, the number of fruit that we're seeing. There's projection models that we run projecting that through to harvest, and the clients can then access this data all in our web platform. The drone imagery, as mentioned, is collected sort of 1 to 2 meters away from the plants. Again, we're using off-the-shelf drones here, but have built our own sort of quite sophisticated algorithms to collect this data as optimally as possible. Flying in these environments can be super difficult. Like, as you can imagine, each tree is different, each orchard is different. These drones often aren't made for this level of precision in data collecting. And we're trying to optimize for speed of collection, quality of data, and just making sure that the drones don't crash. This data gets uploaded, we detect individual fruit on the canopy of the tree. You can see some examples here in the images just circled in red, which is run through our sort of computer vision models. And this is done using deep learning. It's just convolutional neural nets, and we've got an annotation product and pipeline that we run to train these models. As you can imagine, there's a lot of challenges here in that a lot of the fruits are occluded. We're only seeing fruit on the canopy of the tree. There's false positives. We're detecting small green fruit on a big green tree. It can be quite difficult sort of handling those sorts of cases, but we've built a whole lot of different approaches to deal with that. We run at the moment some post-processing on this data just to clean it up, to account for some of that information or those challenges. And there's just different classifiers that we run there to remove outliers. Outliers here could be fruit that are on the ground because they've fallen off the tree, which you obviously wouldn't want to include in your estimate. And we're looking now at whether we can consolidate this into one model. We also size the fruit. So the way that this is done is it's a monocular camera on the drone that's moving. We collect multiple frames of the same scene, and we're able to triangulate and measure fruit level measurements. On that side, we're getting within 2 millimeter precision on an individual fruit level at the moment. But as you can imagine, this is a very, very difficult sort of level of precision to achieve. And yeah, this is all exposed to the client, as I mentioned, through our web application, in the form of aggregated metrics on a block level of the distribution of fruit that you're seeing, projections, etc. And we're seeing a lot of success with this product as we take it to market. So yeah, I think that covers pretty much everything from my side, and hopefully gives you a bit of a snapshot of what we do and some of the challenges that we face. And happy to take any questions if there are any.
Yeah, so we have a couple of questions indeed. So thank you for the talk. It was extremely interesting, as we can see also by the amount of questions we got. So the first one is by Wissam. How do you deal with different visual conditions that you get from the drones? And do you need specific computer vision models to deal with such?
Yeah, so it's a good question. And I mean, in a couple of ways. One, we try to control the sort of data capturing operationally as best as possible. So we fly at specific times of day. We get pilots to fly under specific conditions where controllable. There also is onboard processing that we do to control like the exposure of the camera, etc., as best as possible. And there are computer vision models that we're running post-processing this data. An example where this is a challenge is, I mentioned we measure the color of the fruit that we're seeing on the tree, which obviously can be very sensitive to the conditions where on the tree the fruit is, if it's in the shade, if it's not in the shade, etc. And we've built a whole lot of proprietary models to deal with that.
And the next question by Martha, how often do you update the information of high-value yield crops?
So just to make sure I understand the question, I guess is we collect data at about 3 times during production. So from fruit growth through to harvest, we'll collect data at multiple stages just to account. I mean, you're building a forecast of this data. It's obviously likely that farming practices or weather changes or things happen in between us collecting data that we wouldn't be able to forecast or predict. So we collect data at multiple points to try to account for this and improve our estimates. And similarly, on the crop performance side of things, we'll fly sort of 2 or 3 times during the season. It's all done at very sort of specific phenological stages of fruit growth. So on the yield estimation side of things, fruit goes from flowering through to sort of fruit set, through to fruit growth. And we'll fly at different stages of that production because the farmer would sort of have different interventions depending on the time of season. Hopefully that answers the question.
I think it does. And quite related to that, Enrico asked, with that data granularity that you basically have, right, of all the trees, how do you technically really manage that data and sort of version that?
Yeah, so with difficulty, this is a big challenge that we've got at the moment. We're actually busy working on sort of improving our internal data strategy and architecture at the moment. But it's all very carefully curated. We've got a data operations team who are responsible for ensuring that the quality of the data is as sort of accurate as possible. There's quite a lot of sort of human in the loop involvement at the moment and agronomic involvement just to ensure the consistency and quality of the information. And then technically, I mean, we use a lot of AWS stack just to make sure that this data is sort of as accessible and reliable as possible. But looking at different ways to sort of embed that and expose it as best as possible. I think only now is the scale really becoming a challenge to handle. And also just apart from the database entries, the imagery itself is obviously quite sizable that we're dealing with and running a whole lot of sort of compression algorithms to try to account for that.
Yeah, I can imagine that. Two slightly different questions. Wasim asked what will help you develop in more other African countries? And related to this, Aitana asked how expensive the service is and if that is probably a reason why it didn't yet apply to other African countries.
Yeah, so yeah, like you said, 2 very related questions. I think we focus very much on high value crops. And we follow the markets where these crops are rather than sort of pursuing, I guess, more proximal markets. And the reason being that we found that in, say, citrus as an example industry, just the value of the underlying asset that's being farmed justifies spending sort of the amount that we charge on collecting the data to analyze the tree. Because finding a sick tree is worth enough to kind of validate this. And we're charging about $12 an acre at the moment per year. It's on an annual subscription. We do work in some other African countries. We're exploring some North Africa in particular at the moment where things like citrus are meaningful crops. The constraint for us more than price, to be honest, is just a lack of a network in those countries, lack of partners. We work quite closely with industry partners. And also from a pilot perspective, so our supplier network in drone operators is very much a sort of leading requirement for us to enter new markets. And we're starting to have some conversations now, and likely in the coming years, we'll look at expanding into those markets. I think, yeah, just final point for any sort of tech startup focus is the biggest challenge that you've got. And we've been quite firm in trying to limit the number of dimensions that we're working with in the business, just while we build the technology itself out.
Okay, thank you. I think we have time for one more question. by Meraf. Do you also infer recommendations from similar farms? So basically, do you use data across farms to make predictions?
Not yet. We're starting to, and this is a big exercise. We're calling it benchmarking, and your ability to kind of measure how you're doing compared to similar scenarios. I think it's an extremely valuable proposition for farmers that because this data just isn't available to begin with. And now that our data sets become sizable enough, that's a potential way of looking at things. I think there are data privacy concerns that a lot of growers have with this, and we're trying to figure out exactly how we can position this and aggregate data in a way that it's anonymized as best as possible.